Hello, welcome back. Today we are going to see another interesting topic on crystallography. Can we have edge-centered lattice in crystal system? The edge-centered lattice is nothing but the points at corners of the unit cell as well as at the center of the edges, all the edges. If you have such periodic repetition, then those things are called edge-centered lattice. Is it possible to include in the crystal system or not? That we will examine today. Let's recollect the definition of lattice. The lattice is a three-dimensional periodic arrangement of points in space. In earlier lectures, we discussed that translation symmetry must present in the lattice. If the translation symmetry is absent, then we cannot say it is lattice. And of course, this is the defining symmetry of the lattice that we have discussed. If you are not watched that, you can see I will give it in the reference. We also can recollect the types of lattices which we discussed earlier, that there is a basically is a two type. One is a primitive, another one is a non-primitive. The primitive one will have the points at corners of the unit cell, whereas the non-primitive will have the points other than the corners, maybe at the body center or the face center or only at the opposite side of the faces. That is called end center. There is a three different varieties like A face centered, B face center or C face center, depends on what phase the points are located. In this particular slide you can see the primitive unit cell or the points are located at the corner of the unit cell, and this is a 3D representation of that, in which the point A and point B is given for a reference. If you translate that particular A to B location, the symmetrical operation as well as the unit cell positions remain same. That means it preserves the identical location of the earlier setup. So that must be present for any kind of translation. Similarly, we can also see in the face centered lattice, here also we are given for reference at location A to B, even if it is shift or when you translate to that location, the face center lattice setup remains same. So this is one character must present to define or to say it is to qualify as a lattice. In the same manner, we also can see in the body center lattice. Here the similarly what we can see from the location A to B or B to C, if the translation happens, all the points are the identical location of the unit cell preserved. We can examine the same definition here to evaluate this edge-centered lattice. Here, if you observe carefully, that corner point, if I shift to the of the vector in x-axis, then you can find as the location at a by 2, that is a unit cell length. If you take as a then the black to green point, if I shift, it is a by 2. Similarly, there is another brown color point is given in the picture. If I shift, there is a lacking of particular point in the unit cell. That means the identical is missing, or we can say it is a not equivalent to the earlier existing setup of that edge center. That's what this is not qualified to say to be a lattice. That's what the edge center lattice is impossible to include in the crystal system. So this is the basic understanding one must have, that the translation symmetry is a defining symmetry for the lattice. Since the translation symmetry is absent in edge center lattices, it is not qualified to be in part of the crystal system. Thanks for watching. You can comment and you can ask any doubt related to any of this topic, and also please subscribe, share and like the videos. Thank you.